In the third part of remote sensing video tutorial series, I am going to talk about remote sensing image classification using Snap Desktop. As usual, you can find the link to my tutorial website here. And last two part are uploaded in the YouTube. So first part explains about the basic operations like downloading spatial and band subset and visualization. And next part explain about different type of band combinations uh, and some raster processing like NDVI, NDWI, and filtering, and then principal component analysis. So, in this part, I will talk about image classification. We use two different types of classification: unsupervised classification and supervised classification. So, I have some explanation here. There are what is unsupervised classification and what is supervised classification, and what are the options for each of the classification, and very brief explanation. So you can read the explanation here. I am going to show the uh, how to do these classifications. So let us first of all use this unsupervised classification using k-means clustering, or you can try ISO data clustering. So first of all I will display the subsetted image. This is the subset. So double click this one and it is displayed here. So I can display the RGB window, and as we could see that we have very few combination of colors here. So I make resample it because some of the bands are 10-meter resolution and some other bands are 20-meter resolution. So resampling makes both all the bands same resolution. So we use raster geometric and then resampling. So resample will be here. If you want to use it for future, we can save it in the beam dmap format. And the sampling parameters, we use B2, which is 10-meter resolution. So we can choose the nearest or bilinear, whichever resampling method. So let us run this one. So it is very fast. So even if there is error, the data is already created here, and now I can create more RGB as I explained before. So there are various ways to display the false color images. So I will use this second product for the further processing. So let us try the unsupervised classification. So as I explained here, I'll be using first of all PCA bands, and then I'll be using NDVI and NDWI. So I will open the product which I had created before. So processed products. So I have this PCA. So this PCA will be displayed here, and then I'll be using NDVI and NDWI. So we use raster classification, unsupervised classification. So let us use this one, raster classification, unsupervised classification. So K means cluster analysis. Another one is EM cluster analysis. So K means cluster analysis, and we use the PCA bands, and processing parameters are only first three bands, and we classify, for example, into 10 different classes. So let us run this one, and it will be saved inside this K-means classification. So the product is produced. So we can see this class indices, and it is displayed like this. So we don't know what is what. So we display the resampled RGB image side by side, and we first of all we should find the so this area is dark green, so it should be heavily forested or maybe plant vegetation area. So we can check the pixel info. So you should write down the class indices. Here it is 8. So 8 is uh, dense vegetation. So in the color manipulation, we should write like class 8 is dense vegetation, and color it uh, like dark green. So we should find the river area. So this may be river. Or maybe just river sand. So this is also okay. We made some mistake. The class value 8 is this one. So this should be dark green, and this should be river sand. And this may be dense vegetation. Now let us open this class indices, and we don't know. So we have produced this k-means classification, and this is the class indices band, and we display this, and it will be given random colors. So we should compare with the original RGB image. So let us display the RGB image and compare these two images. So for example, so this is plantation area, vegetation area. This is maybe a bit dense vegetation. So we need to check what is the class here. So let us see. For example, this is class 3 here, and the vegetation is dense. So 3 means dense vegetation. So this is 3. 3 is class 4. So 3, we make it green, dark green, and name it dense and this is vegetated area. So we change this. This is class 1. So this is vegetated area. So we choose this color and name it farmland. And this is river sand, we can see, and here it is 8. So this 8 value, this is sand, so we make it white. In the same way, we have to find each of the product, each of the classes. So this is also somewhat dense vegetation. So I think this 0 value is also dense vegetation. So let us make it So this is also now we need to find other unclassified area. So this is 7 and 7 seems to be road or built up area. So let us make the built up area and road as same. Maybe this is 8 and this is 7. So 7 is road. Let us make 7 road. So we can see that the roads are here, and 8 may be built up area, or 7 is probably road. In this way we find each classes. So this is my final product. So in the next part I will use PCA Bands along with NDVI and NDWI. So I will display the I will calculate the NDVI for this one. Or I can use this NDVI already calculated in my last tutorial. So let us display these products. NDVI. I will only include NDVI. So this is NDVI, not NDWI. So NDWI is here. So I will include this NDVI along with this PCA bands. So to include this NDVI in this band, we can use uh, band maths. So let us use the band maths raster band maths. So I can write NDVI and expression is from this NDVI. So expression is written here. Now the NDVI comes from another product. So I click OK. OK. So NDVI and this PCA component 1, 2 and 3 will be used for the classification. So processing parameter, we will use first 3 components and NDVI. So 4 components we'll use, and we'll have 10 different classes. And IO parameters, K means, so it is second, Now we have this k-means using NDVI is displayed here. So let us display this class indices here, and we maybe we can find some differences between the first class indices. So we can display horizontally, and maybe we can remove this. So now let us do the same thing here. We compare with the original one and change the class name. So this is the final output of this second uh, k-means classification, which I used with NDVI. So in this way we can compare different ways of classifying images. Now let us talk about supervised classification. So in case of unsupervised classification, the software produces different classes by itself. But in case of supervised classification, we give some known area as training area and then ask the software to classify based on the training area provided. So there are several classification algorithms, and we need to refer to the corresponding uh, references to find what is the meaning of these classification algorithms. So I am not going to talk about the classification algorithms here, uh, but I will use the Snap desktop to classify the uh, land use. So first of all, let us fix what are the classes we are going to use. So I will use, in this case I have written PCA 1, 2, 3, but instead I will use uh, all the components of PCA for the practice. So first of all, let us build training areas. So I have this water body here, and the roads and green area, some are densely vegetated, some are sparsely vegetated. So we classify the land use into these classes: built up or barren land, forest or dark dense vegetation, and then cultivated farmland, river sand, water body. So all those which are not classified by the software will be kept in this unknown class. So let us try to build some training area. So we use vector and new vector data container, and we draw some polygons or rectangles or ellipses like this. So first of all, some water body, it is very unclear, but still I will assume that this is water body, as I could see this in the Google Earth. So I will draw some polygons, vector, new vector data container, and let us say water, and write some description, and OK. Then let us draw a polygon, for example, very thin area, so this is created. I'll draw another area, in this way we can create several areas with water, but in my case water body is extremely few, so I will draw these few. We need to draw as many polygons to get a better result. So this is water body, and I will create a new vector data container, and this time I will create farmland. So I will draw some rectangles. So we have to choose, after we draw more than one container, then we need to select this. So these are farmlands. We can even differentiate between different farmlands. So, but I will use only single category. All are farmlands. We can select various places. Okay, so now again we create new area, forest or dense vegetation. So I have written both the same. So where we see the uh, dark patches, we create this uh, now we create the road. So new vector data container, road, road surfaces. I delete that one. I am creating a new road surface. Now we create some barren lands like this one, and these are some barren lands. So let us create a new container. So now we create a built-up area like this. So we don't know exact uh, boundary between the road and the built-up area. So we take these areas as built-up area. So let us create a new and now finally we create the river sand. So maybe the river sand and barren land may have different uh, spectral characteristics. So let us see whether river sand is differentiated by the software or not. So we create one more. And we draw the river sands. Now I have finished the creation of all the vectors. Now I will explain alternative method of creating training data for supervised classification. So I have displayed this RGB and this PCA band side by side. So we will export this resampled image as TIFF file. So from export as GeoTIFF. So I export this product. Now I will open this image in QGIS. This is the sample data. So this is displayed here, and we will create a vector layer for training data, and this is the classification. So we will classify into 7 different land use classes. So the benefit of using QGIS is we can display Google Earth in the background, and we can see whether what kind of land use class is there. Okay. So let us create a land use class. Layer, create a new, because Snap Desktop only accepts shape file, so I will use shape file. So I have created this already, but I will show you how to create. And we will use this ID. And then geometry type is polygon, and this projection is UTM-45N. Okay. And we will use this 1, 2, 3, 4, 5, 6, 7 for the ID. It's representing these classes. So first of all, I will classify as the symbol before I start on-screen digitizing. So this is categorized symbol, but if we classify there are no features, so it will not show any feature. Still we can add, like we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7, and choose different colors. So as I have already created this symbol, so I will use my own symbol. So let us load the symbol from my previously created color. So this is land use symbol. So now we can see this water is blue, farmland light green, and dense vegetation, and so on. We can also write the legend here like water, farmland, and this is barren land. Okay. And we can start digitizing. For example, let us suppose this is the road. This is road we already know, and we can see the background by making it a little bit transparent. So transparency we can put 50%, and we can see behind this is a road. So we start digitizing, we can start digitizing over here also, but for the barren lands maybe our original image is different from the Google Earth, because the time of capturing image may be different. So for the roads we use this background image, and even for the water we can use this. So we can see that water is here even in our image. So I'll first of all create water road section. So this is how we create. So ID for the road, the ID is 5, so we write 5. Okay. So in this way, so river we can create like, so we should create as many features as possible to get a better result. So for example, this is the river. So river is number 1. So in this way I have created all the features. So I will directly show you the created features. So I will remove this one, and then I will display the land use. So I have created this land use, and if we can see that there are more than 20 features here. So I have one more attribute here, so I will remove this one because in our example I have not used this, so I'll remove this land use field. And this is IDs, and we can see that the color of each feature based on the ID, so we can use this symbol. So we can see that I have already digitized and reverse and built up area, road, etc. And also some green area, farmland area, and barren lands are here. So next step, because when we export this to Snap Desktop, it will create 30 different polygons. So we need to merge these polygons into different types. So this is called collecting geometry. So let us select collect. So if we collect geometry, then so we use ID for, if the ID are same, then it will be created into one single feature. So we can save it as save file. So it is save file. So I have already created this land use merge, but still I save it. And so if we see this attribute, so there are only 7 type of features. So if we select for example 7, then it consists of 2 different features. Similar way, we can see the river sand and roads, multiple roads are selected, so it is collected into one single geometry. So now we add one field. So for example, land use, it will be the name, so it is text, and in the beginning we keep it empty. So now land use 1 is water and 2 is farmland. You can also join these two data, or but I find it easy because there are bigger. So I again create this text field. Because it is only 10, so that is why maybe 10. So default is 10. That is why we had problem. So we increase the length like 20 and repeat this, and now we can see. So we can save this one, and now editing is off. So now I can import this to any of this product. So let us import this from ESR I save file. So land use merged, open. So 7 polygon shape and we use S. So from the layer manager we can show for example, we select this product and from layer manager we can show all these. So we can see that the data is this. So now we can use supervised classification, but it is obvious that the result may not be very good because we have very few training data set. But I will only explain the process. So raster, image classification and supervised classification, we use random forest classifier, and we can use multiple data. For example, we can use like this one we don't need, this one also we don't need because the resolutions are. So it is showing a resample, so I think we should better remove this one. So now we can see all the data, vector data listed here. So let us use only single product. If we want to use multiple products, then we have to import bands to another product. So we are not going to do that here. And we select all the land use classes and we select all the components and we'll write the data like this. So it may take some time depending on the size of the image. So when I run this one, it will take a little bit of time. Now our resampled PCA has produced this random forest classified image. So we can check in the bands and we have this labeled classes and we display this one and we close this PCA band and we see that the image is classified like this. So we change the color of each barren land. We can make it like this color, and road, this is okay. River sand, I think white will be better. Dense vegetation, we make it a bit dark green. And built up blue color, water built up pink color, and farmland green color. So we can see this output and we can check whether it is done correctly or not by validation. For example, we can create 100 random points and decide whether it is classified properly or not. So we can see this water, maybe whether it is water or not. In this way we can but classify this uh, using supervised classifications. So this is the end of this tutorial.